Hi, welcome back. So in the last video, we went through the installation and basic configuration of R and RStudio. In today's video, I will continue to talk about the basics of R programming and walk through the steps for data importation. Basically, data importation will always be the beginning of data analysis projects and machine learning tasks. Luckily, R provides several powerful options to complete that mission. I will first introduce the data types and data structures that we might see for analysis projects in R with several examples for each section. And I will finally conclude this video by introducing three different ways to import data into R. There are four types of data that we need to be familiar with in R programming. They are logical, numeric, integer, and character. I will begin with logical. Logical data are Boolean values. They can either be true or false. Let's do a quick example here. We will define a variable named isEmployed and we assign true value to this variable. Let's try to display this variable in the console. It will return true right here. So if we want to check the type of data, there are actually two commands that we can use in R. The first command is the class command, and it will just tell us isEmployed is actually a logical variable, and we can also check for a specific type. Let's say if we want to check if this variable is indeed logical, we can use is.logical. It will return true in the console, which means isEmployed is a logical variable. And if we do is.numeric, it will return false. So we know it's not numeric, it's logical. We can try to convert a logical variable to other types. For example, we can convert it to a character, which means to convert it to a word. So let's do it's logical, and we do s.character. And now this variable will actually be a word true. We can also try to convert it to a number. So let's reassign the Boolean value true, and we do s.numeric. Let's display this in the console. It will assign the value 1 for a true Boolean value if we do the numeric conversion. So the next data type will be numeric. Numeric data can either has decimal or has no decimal values at all. Like we can have height or weight. So for example, we can assign a new variable called income, and it will be this amount, $12,456 plus 78 cents. We can also quickly check its class. So this will be a numerical variable. And we can also do a value with no decimal. For example, we can assign expense to be $54,321. It will also be a numeric type. The next type of data I want to talk about is integer. So integers are real values without decimal points, like age and population. So it's possible that we don't really need to work with integers very often, but it will be really handy for certain situation. So the way to define integer is a little bit special here. So for example, if we define a variable age to be 23, a integer value, you need to add this capital L after 23, this number. In that way, the age variable will be classified as integer correctly. And we can also do, another example like population. So this will be this really big integer value followed by a capital L. You can see right here in the console is also a integer type. The last type of data I want to discuss is character. So character data can be characters, string values such as single words, characters, or even a sentence. For example, we can define a variable named significant day. The significant day will be happy birthday, and this will be a character. Right here in the console, it will be a type of character. We can also do one single word. Let's say we want to send a gift in birthday. Okay, the gift will be a cake. So assign cake to variable gift. It will also be identified as a character type in R. Okay, so that's all we have for the data type section, and the next section will be data structure. There are 5 types of data structures that we use frequently in R programming. There are vector, list, matrix, data frame, and factor. I will begin with vector. So basically, vector is a collection of elements. It is one-dimensional and can only contain elements with the same data type. For example, we can create a vector with ages of a group of people, and they will all be numeric. Let's do a quick example here. We can actually create a numeric vector. So to create a vector, we use this letter C followed by a parenthesis, and we put everything inside this parenthesis. For example, a bunch of values, 5, 4, 3, 2, 1. And we can use the class command to check for the type of the elements, so they are numeric. And there's another interesting command we can try, is the type of command. And you will see in the console it displays double. So there's nothing wrong with our code. This is just how R deals with the floating point vectors. So it has 2 names, numeric and double, both refer to the same thing. Actually, the name numeric refers to the type of data, and double refers to the mode. But we don't really need to go too far into this topic. We just need it to understand they are basically the same thing, and there's nothing wrong with our code. So like I just said, vector can only contain one type of data. So if we try to put different type of data inside one single vector, let's see, we can do a few numbers and plus a few characters. Let's do this. Well, it will still create this vector, but when we try to check for the data type inside this vector, you will see it will automatically convert all the elements into one single type based on R's preference. There are several operations that we can apply to a vector. For example, we can find the length of a vector by this length command. it will return 5 because we put in 5 values inside this vector. And we can actually access a certain elements in the vector by pointing out its index location. For example, we can access the first element, which will be 5. We can access the last element. So the last element has index location 5, which is the last element is actually 1. We can also sort a numeric vector by its value. Let's do sort. And also the original vector is 5, 4, 3, 2, 1. And if we sort it, it will do it from the smallest to the biggest. So 1, 2, 3, 4, 5. Well, of course, we can specify the sort function to do it from the biggest to the smallest. We just need to specify the decreasing parameter to be true, and it will do the sorting from biggest to smallest. So 5, 4, 3, 2, 1. Well, we can also get rid of a element in the vector. So to perform that operation, I will first copy this vector to a new variable, just in case I will destroy it. So this copy numeric vector. So let's see if we want to get rid of the first element. We do this -1. So we get rid of 5. Only left with 4, 3, 2, 1. And we can also get rid of all values. We just need to assign the null value to the entire vector. And now this vector will have nothing inside it, so it's null. Well, we can also try to do well, basically we can put anything we want inside a vector. We can put integers, we can put Boolean values, we can put characters. Well, it just depends on what you need for your analysis project. The next structure will be a list. A list is a more complex but universal container of elements than vector. It can be multidimensional, plus having various data types inside one list. So basically, we can create a list of ages of a group of people and their geographic locations, which could be characters, where they're from. We can actually create a list by two variables right here. So we can have a name variable. They are David, Michael, Edward, and Zach. And their ages, 18, 17, 16, 22. So the name variable will be a vector of characters, and the age variable will be a vector of numeric values. So to create a list, we name this list new list, and we use the list command and put both vectors inside the parentheses. Also, we will do we'll check their class, and now it will return list. Let's also try the type of command. Well, it also returns list, so they just confirm each other, which is great. We can also let's just display this list right here. So we can see it just assigns the index numbers for each of the vector. So it doesn't really look nice in that way. In fact, we can assign names to each vector inside the list. Let's see, we can do name for the name variable and age for the age variable. And in that way, it will just assign the correct names to each vector, which looks much nicer. Also, we can access a specific location inside the list. So if we want to just access the entire vector, we can use this double bracket. So the first vector is the name, and we use double bracket 1. It will just return this entire vector. If we want to access, let's see, the second element inside this first vector, we can use double bracket 1 to point out the vector, and we can use bracket 2 to point out the location, the index location of the element. It will return Michael. Well, we can also just, just specify the name we used right here with this $sign. It will basically do the same thing like the double bracket. Just like that. Let's try another operation for the list. Well, we can add a third vector into this list. Let's create a new variable. So name list add. We will add a new list, which is this thing. The total number of people is 4, and we will add this information inside this list. So now we have the name, the age, and the total number of people. There are various operations that we can apply to the list. For example, we can also get rid of the entire vector by assign null value to the specific location. Well, in that way, we will just keep the first two vectors. And we can also convert a list back to vectors. We can use the endList command, and now it will just be a named vector, and so we'll have the names and the ages. The next data structure will be matrix. Matrix is just like the matrices we used in linear algebra. Matrix in R can have multiple dimensions, but with only one data type. It's more like an upgrade version of vector. So to create a matrix, there are a few parameters we need to specify. So let's first have some data that we can use. Let's define some ages and put them inside this age vector. So to create a new matrix, we need to have the data and the number of rows, the n-row parameter, and the number of columns, the n-column parameter. And if we want to arrange this matrix by row or by column, if we want to do this by row, let's specify true for the by row parameter then. Let's have a quick look of this matrix. There are a few operations we can do to a matrix. We can examine its dimension with the dimension command, dim. It's a 3x3 matrix, just like what we defined in this command right here. We can check for the number of rows. nrow command, 3 rows. We can check for the number of columns, n column command, 3 columns. And we can also get the length of this matrix. It will be 9, so there are 9 elements inside this matrix. Because a matrix has rows and columns, to access a specific element, we need to specify the index location of row and columns. So if we want to access an element at the first row and second column, we just put 1, 2 inside this bracket and we'll return 17. We can check with the actual matrix. So first row, second column, 17. And we can also assign a new value to that location. Let's say we want to, well, that's 17 is actually the wrong age and we want to correct it by age 22. Let's assign 22 to first row, second column location. We can see 22 right here. It replaced 17. We can try to add a new row to the existing matrix. First, we need to create this new row by, well, essentially the same command. So it will be 1 row and 3 column, and the values will be 15, 32, and 40. And to combine the new row and the existing matrix, we use the rbind command. Refers to row bind. And now this matrix will be 4 by 3. We can also add a new column. So let's create this new column first. It's 4 rows and 1 column, 20, 19, 24, 33. And to combine a new column into the existing matrix, we use the cbind command, which refers to column bind. Now we can see it will be a 4 by 4 matrix. Well, we can also do modifications to the matrix by removing some elements. Let's say if we want to remove an entire column, well, we just skip the row index location and we do -4, which means we want to remove the 4th column altogether. Now the 4th column disappeared. And we can also remove an entire row. Let's see if we want to remove the 2nd row. We do -2 and we skip the column index location. So compared with the original matrix, the 2nd row is gone. Next, we will talk about data frame. Data frame is a tabular data structure with rows and columns. It's very similar to Excel tables and very important for numerical analysis. Well, let's prepare some data for creating an actual data frame. We have name and age. To create a data frame, we use data.frame command. So new data frame, data.frame command, and we assign names to each, and we can assign names to each columns, name and age. Let's try this, and let's display this new data frame. Also, it's very similar to Excel. Because it's so similar to Excel file, we can actually output a data frame by CSV file. We can use the write.csv function, and the first parameter will be the data frame, And the second parameter will be the file name. Let's do a test.csv. Execute this command. We can see right here, we create a new CSV file, test.csv, with the data we put into the data frame. So that's a basic introduction for data frame. And well, now we will talk about factor, which is the last data structure we'll talk about today. So factor is an alternative expression of characters by using integers to represent different data categories. We will use that very frequently in machine learning and data analysis projects. Well, we will also need to apply some other techniques like one-hot encoding or ordinal encoding to factors, which we will talk about later. So to create a factor, let's see, we can use some grades, 11th grade, 12th grade, 10th grade. We can use those grades to create a factor. To create the factor, we use s.factor command. Let's see, we name a new variable grades factor, and we do s.factor command to this character vector. And now, if you check the class of this new variable, it will return factor right here in the console. One interesting about factor is that we can apply a new command summary to the factor variable. Well, it will just return us this nicely done summary report thing. We have 1 student from 10th grade, 3 from 11th grade, and 2 from 12th grade, which is quite useful when we need to deal with a large amount of data and we need to pre-process them. So that's pretty much everything I have for data structures, and we will go right into the last topic of today's video, data importation. R provides a lot of options for data importation for different types of files and with different R packages. I will go over 3 of those commands in R, but you are more than welcome to explore and investigate other options as well. So the first command will be read.csv. If you recall that we just used write.csv right here, so basically they are they are from the same package, one for reading data and one for output data. So, well, the nice thing about read.csv is that although it might not be the most powerful importation command in R, but it comes with the standard R installation, so you can use it right out of the box. Let's try this command. So we can have data1. Let's name this data frame to be data1, and do write.csv. So there are a few options for this command. I will just perform a very simple importation. Just name the file. So well, let's just import this test.csv back into R. Well, we can see it has this additional columns here, X, 1, 2, 3, 4. That is because we've actually forget to add a parameter when write the CSV file. We can do right here, row.names equal false. So it will not automatically give each row a numeric value as its name. Let's do this first. And well, let's try to import this CSV file again. Well, and now everything looks normal. There's no that additional column. So Well, that's the read.csv command. Actually, there are a lot of parameters we can use in this command. We will explore them in more details in my later videos when we actually do pre-processing of the data and do analysis projects. Next, let's check out the read underline CSV command. So this command will use an alternative table format instead of the classical data frame format. Well, it can be really handy for large scale of data and well, if you prefer to work with the tidyverse universe. So this command doesn't come with the standard R installation. Well, you need to install the radar package, or you can install the entire tidyverse package instead. So well, we need to first load the package radar. We do that by the library command, and let's see, we can do data2 and read underline CSV. Well, we do the same file again, and the CSV file is loaded successfully. We can examine this. Well, so you can see right here is in table format. Well, and a table is very similar to a classical data frame, but it will be used by the tidyverse packages only. And we will also talk about that in further in my later videos with more details. And the last command I want to introduce is fread. So the fread command belongs to the data.table package, which is an extremely powerful alternative for big datasets. Data.table can natively use multiple threads in Windows and Linux, while it will only be one thread, a single thread in Mac OS. So if you are using a Mac, it might not be the best option for you. So the multiple threads nature makes data.table package to be super efficient in large-scale projects. Also, the command lines follow a SQL-like style in data.table. If you do have related experience in SQL, you will get used to data.table package fairly easy, and the transition will be super smooth. To use fread, still we need to load the data.table package first. Well, in the console, you can see, well, my PC has 8 threads CPU, so it will give you a reminder. It will use 8 threads. Let's load the same CSV file again to data3 by fread. Well, you might not see the speed difference here because this CSV file is so small. Right, and well, it looks pretty similar to the classical data frame. So, well, in short, for most of the time, you will just be doing fine with read.csv function and the classical data frame. Well, but please keep in mind, there are other more powerful alternatives in R, and well, I do encourage you to do some explorations by yourself. You can always refer to the help page, and you can also get some online resources. We will also talk about all those importation techniques in more details in my later videos. We will also go over some actual projects in data pre-processing, numerical analysis, and machine learning tasks.